and welcome back everyone. My name is Gwen and today I want to talk about software architecture. If you've watched my videos before or you've been following my channel, you might know that I've mentioned that I've been studying software architecture for several years now. Especially working as a staff level engineer, as a tech lead, I've had to be responsible for architecting more and more software systems and parts of systems as I, advance and grow in my career. So this has been a really big interest of mine. I've been reading a lot of books and blog posts, and I'm excited to share with you what I have learned. I think software architecture is really important for every developer to know. So even if you just have a little bit of experience, I hope this video can still be helpful for you. And especially if you're interested in someday being a software architect or maybe working in a staff level role. So this is my first video on architecture. So I want to cover some of the basics, and I also want to briefly go over some career advice and also some tips from things that I've learned over the past couple years. Now, I want to demonstrate these concepts visually, so I'm going to be using a tool called Eraser to diagram as I go along. And Eraser has nicely agreed to also sponsor this video. So while the video is about architecture, if you do like the tool, then follow the links in the description below to check it out for free for yourself. I hope that seeing these concepts visually will help you understand. And if you do have any questions or comments, please leave them in the comments below this video or check out my Discord linked in the description below to continue the conversation. Software architecture can be kind of a complex topic, so I want to show a couple demos to help you understand it and go through some of the actual tasks that you might have to do as a software architect. For these demos, I'm going to be using an app that I've used quite a bit on this channel called the Curriculum app. You can find it on my Faraday Academy GitHub. If you look at the README, you can kind of get an idea of what this app is doing. And basically, it's a place for you to create and manage your own learning curriculum and keep track of your progress as it goes. And you can see from the mock-ups here what you're actually doing and how it works. And basically, I'm going to give some examples where I'm planning this application as if I was planning it from scratch, and then also planning a new feature in the way of writing a design doc for this application. As a follow along, I created this GitHub repo under the same GitHub organization. It's called Intro to Software Architecture, and I'll link both of these in the description below. As I mentioned, I'm using this tool called Eraser to demonstrate this and do the diagrams as I go. So you can go to eraser.io and sign up for an account. And then the only other thing I did actually was use GitHub Sync. So you'll have a button here, or you can also go into your settings, and it's pretty easy to just follow the flow and sync a GitHub repository, and then you'll see any READMEs you have in that repository. If you want to practice diagramming though, with what we talk about today, you can also just create a brand new file like some of these examples down here, and then you can just practice creating diagrams. So I'm going to go back here, and to get started, I'm going to go into this Getting Started in the Sections folder. Let's start by defining what software architecture is. It's basically planning for and making technical decisions about the design of a system based off of business or user requirements. That can include system design itself. It can also include planning for DevOps, infrastructure, and the technologies that will be used. Now, I tried to simplify the definition even further into planning and making decisions about how you will build something. So if you are the one planning and making decisions, then you're kind of leading people from a technical perspective. So technically leading and giving the direction for the design of the software. Of course, the architect has to keep in mind that the decisions have to take into account the requirements for the project. I think that pretty much sums up in general what software architecture is. Now, what does that look like in practice? I kind of made a general overview of what that might look like. there is an upfront piece of software architecture before going into actually coming up with solutions and creating the architecture proposal. And that first piece is reading requirements very thoroughly and researching and interacting with anybody who is a domain expert, like a subject matter expert or a stakeholder that you can gain information of or from. So it's basically like an investigation, and you're trying to figure out all of the details so that you can come up with the best possible solutions for the problems. Now, once all of your questions have been answered, you've done some investigating, you've worked out the requirements, you make sure all the details are there for the requirements, then you can move on to step 2, which is going into a deep state of focus and analyzing solutions, taking into account any trade-offs that might come with those different solutions, and then finalizing your plan of action. Now, I emphasize here going into a deep state of focus because I think this is a critical piece, of course, in software development, but especially in software architecture. You're designing the foundation for systems or whatever is going to be built, and there's a lot of things to think about and to take into consideration, from all the different possible solutions to trade-offs. And as in software development, if you're not working in a deep state of focus when you need to, then a lot of mistakes can very easily be made, and at this stage they can be very costly mistakes. So once you've analyzed different solutions, compared trade-offs, and you've come up with a plan, then you'll put all of this information into a more formalized document for a new application that might be called an architecture document or proposal document, or a lot of times from software development you might be used to seeing this term, a design document. So you can make an architecture design document for new features. That should include all of the relevant information as well as diagrams, and we'll get into an example of that a little bit later. And of course, once you make this diagram, unless you're the only person working as a technical employee, then you're probably going to have to get buy-in from other people at the company. They could include key technical people and definitely whoever are stakeholders in that project or at that company or clients. So you have to get buy-in from them, and that will include getting any feedback and answering any questions that they have. I think a lot of times it's a good idea to walk through an architecture plan in person with your client or other people at the company. And then, especially for larger or more complicated architectural plans, you'll inevitably get feedback, maybe both from a technical perspective about the design to a business perspective, like, does this actually meet our business needs, or can we make this align a little bit better with such and such objective? So it may be necessary to iterate on that plan. And then once it is approved by any necessary stakeholders, it's the time to hand it off to the engineering teams or engineering leadership and help advise them on creating the plan of implementation. So this is just a general overview that might look different at different companies. Now, as I mentioned here, some companies will have an architect or a team of architects that kind of are managed separately from developers, or just specialize in the architecture role. But a lot of times, I think especially with the adoption of Agile, which includes less upfront planning and more iteration, there's more combined roles, especially at smaller companies. So like the role I took as a tech lead, responsible for architecture decisions and planning and writing design docs and things like that. But I also work with the developer team and do development work myself. Some companies have different opinions about dedicated architects versus integrated architects and dual purpose roles, but I'm just mentioning them because there are many different ways to perform or have the responsibility of software architecture without maybe the title and sole focus on software architecture. So before I get into demos, there's a couple more things I want to mention. First, I want to go over the common types of architecture Now, if you've been around software development, I'm sure you've heard of monolith and microservices. And I think the easiest way to describe monolith, I don't want to go into too much detail, but if you're building a project and it's all in one repo and you're deploying it all together, it's called a monolith. Let's say I'm building a Flask API, and let's say this is a health app and I'm tracking user behavior, exercise, eating patterns, all of that kind of stuff. And another feature is that it generates reports for users. Now, if I put that all in one repo and deploy it all as one application, then it would be a monolith. Now, if I took that same application and divided it up along logical business verticals, let's say I took the reporting feature of that application and kind of spun it up as its own separate application and just made it talk to the core or the main application that I just split it off from, that would be creating another service. And this architecture is generally known as a microservice architecture, where you're basically creating and deploying different services together, but all these different services actually make up your application. Now, there's some pros and cons to it. If one piece of the application is used a lot more than the rest of the application, gets a lot more traffic or whatever, then you have the flexibility to scale that part of the application independently, up or down. If you're making several smaller services instead of one big monolith, it can also be easier to update, make new changes, implement new technologies, because you're just working with a smaller code base, basically. Now, this term has been a very hot buzzword over the last however many years. And so a lot of companies, whether they need to or not, started to adopt this type of architecture. I don't want to get into too much of that in this video, but maybe I'll make a follow-up about that. But I would say the biggest con of using a microservice architecture is the complexity. And especially if you're at a smaller company or a startup and you don't have someone dedicated to the DevOps role, it can be quite challenging to create and maintain this type of architecture. So a lot of times people will start off with the monolith approach, and then as needed or where it makes sense later on, start splitting things out into different services one by one and keeping their main application and just deprecating it piece by piece as they split out services. A few more terms or types of architecture I want to point out. This one became popular, of course, with the advent of the cloud and serverless architecture. And it's basically an abstraction on top of servers so that you won't need to manage servers or infrastructure yourself. And it can be very cost effective for certain types of projects because you'll only pay for the resources that you use. And sometimes those resources just spin up when you need them and will hibernate if you're not using them. Of course, this comes with its own set of challenges sometimes. A lot of times, for example, if you're in the AWS ecosystem creating serverless, you're using tools like AWS Lambda, which is specific to AWS. And you're coding inside of that abstracted environment. So you're kind of locked in, as they call it, vendor lock-in. Let's say your costs increase or you have some kind of needs that aren't reasonably provided on the platform that you're on. You want to switch platforms. It can be quite a bit harder to switch in a serverless architecture versus just an app that you built and deployed fully by yourself that you could just write a little bit of deployment code and deploy it anywhere else. I have some videos on my channel about serverless architectures if you want to check those out. And then finally, evolutionary architecture. I want to mention this one because this seems to be what people have been talking about for a while now in the software architecture space. And it's basically the idea that you can make or design software that's adaptable and prepared for future changes, especially in today's agile world where we are constantly iterating, business requirements might be constantly changing. We might have to constantly update or change technologies. So there are ways and tools and methods for us to be able to prepare for that and architect in such a way that it's easier to update our applications in the future. Of course, evolutionary architecture is kind of an idea or set of ideas, and different people I've seen have different ways that they specifically implement this. So maybe I'll talk about this in a future video. But I think the biggest barrier is the knowledge of how to do this. Like, how can we make things that are easy to change, easy to add or remove things as our requirements change? So I wanted to point this out because I think this is a really important topic that people don't often discuss. When people think about architecture, it seems like they're often thinking about these greenfield projects, in other words, architecting a brand new application and getting to plan from scratch. Sometimes these are the most exciting applications because there's more freedom and fewer constraints. So a lot of people want to work on these types of projects. But I think more common in software architecture or just in development in general are working on projects or updating systems that already exist. Now, this could be adding new features to a current project, which might be partially greenfield because you're adding something new. But a lot of times it's also updating based off of new constraints. Or maybe you built something that would handle 10 rows in the database per user, but now you realize users are actually, doing a lot more uploads than you thought. So now there's tens of thousands of rows per user. And when they are pulling this information, the page is crashing because you didn't plan for that case to happen. So now you have to kind of re-architect a little bit and see how you want to handle that. Another case is where you're going in as an architect to assess problems with an application that the whole application isn't really working out or it's very buggy, seeing if it's better to fix it or build something new. And you'll need to come up with an assessment of the situation, research some potential new architecture proposals, and then present that information. These are just some ideas and examples that I have from my own personal work and from learning about architecture over the years. Let's move on to what to pay attention to. I would say the number one thing up front is making sure you thoroughly read and understand requirements. I mentioned this earlier, but it cannot be understated. This is why deep focus is so important, because if you miss something, you're kind of building the foundation that everything is going to be built off of, or you're building the blueprint. So if something is wrong with the architecture plan because of a missed requirement, that's a great tragedy. The second thing is trade-offs. And I think the hardest thing for especially people who are newer in tech is that they kind of have this tunnel vision where they think the tool or technology that they use and that they like is just so much better than everything else. And it's hard for them to see outside of that because they really don't have enough understanding or experience to be able to see and analyze trade-offs. Because every decision, every technology has its pros and cons in terms of cost for the business, complexity, maintenance, so many different things to analyze to decide whether or not that decision is worth it. And that's really one critical skill of a software architect, is being able to zoom out, look at everything from a high level and unbiased perspective to make proper decisions. And this kind of goes along with evolutionary design. In general, it's just important to be able to make systems to adapt to future changes. And I would say also see ahead as far into the future as you can. Like, if you know that a year or 2 years from now, your company goal and trajectory is to be in a certain place, you can make decisions now to help your future self or to help your future client. So the most important things I think to learn if you're just getting started in software architecture is first how to write planning documents, so architecture documents, design documents, It's great practice to write a design document for any piece of software that you're building, or maybe a new feature, or even a small ticket that you have. You can just practice writing a design document. I think that doing this also helps stay organized a lot, and it's a great tool for effectively communicating ideas to other people. The second thing that I think is very important to learn is how to diagram. Sometimes a visual can help explain something so much better than words on paper, or just telling somebody. Creating a proper software architecture diagram, and there's different types like component diagrams, flow diagrams, but knowing a few different types and being able to know how and when to create them is critical in the role of software architect. And even just for any software developer, really, I think they should be able to draw some of the basic diagram types, because even as a software developer, especially as you progress to senior level or beyond, you're almost definitely having to write some kind of design document for at least new features that you're making. Next, I wanted to show you an example of how we might plan an application and write a software architecture document for it. And again, I'm taking this application, the curriculum app, and kind of replanning it. So if you go into this curriculum app demo folder in the GitHub repo, and this app requirements.md file, you can see this document just has some of the functional, non-functional, and a couple business requirements for kind of the minimum viable product, or MVP, of our application. I just included some here for having users that can log in, log out. We need to have the ability to manage a curriculum, so a user can create, view, update, or delete them. And then inside of each curricula, there should be a name and a goal, some other metadata, description, and then you can add sections and resources as well as projects. So I think this is pretty much the core piece of the application, and then users can keep track of their progress as they work through their sections and courses. So those are the functional requirements of the system that we have to account for. In other words, what the system has to be able to do. Now, if we look at the non-functional requirements, but still important requirements to consider, things like performance and scalability, and of course we have to maintain some level of security for our users and our business, and plan this in such a way that it will be maintainable in the future. So these are the requirements that I have been given for the application. Now, if I want to be able to plan the architecture for here, of course, since I built this and wrote this, I understand all the requirements already. So I can go ahead and start creating an architecture document. So I have two templates that I put in this repo that you can use. And I'm going to use this one for creating a new project, this new project template. And it basically just breaks down different sections that you might want to include in your architecture document. Of course, with this template or any other template maybe you'll find it online, you don't really have to use every single section on here. It's just a good template to start with, and then you can add or remove or change things as needed. But you'll probably want a lot of these sections in your proposal. It definitely keeps it well organized and makes sure you aren't forgetting things. That's why I use templates for everything, for design docs or whatever. I'm creating something new, I already have a template and make sure I don't miss anything, and then I can just go in order and fill it out. So I actually have this template already filled out over here. If you go under design docs, you can see the curriculum app greenfield. I don't want to do all of this typing live, so I actually created this document mostly already, and I'm just going to walk you through some of the decisions here. So first I describe the purpose for what we're building and the purpose of the document as well. So it outlines the architectural plan for the MVP of this curriculum app that we're designing right now. And a reminder that this document is for not only the development team, but also for potentially non-technical stakeholders and anyone else who might be working on this project. And it's really a guide for that initial development and how to build off of it with future enhancements. Scope is a really important part of these documents, and it's easy for this one because it's just the MVP of this application and what that entails. Here are some definitions. These are obvious, but I just put them here as an example. And then if there's anything in here that needs referencing, maybe a certain pattern that we're implementing or some type of documentation. For this one, I just put some documentation here that of tools that we're going to be using. This is the overview of the document. If you have a bunch of details here, you could put this in bullet points. I just put it in one sentence to make this short. And now we get to the actual architectural decisions. So first, this is a pretty obvious choice for the stage and scale of our application, but we're going to not overcomplicate things and just use a standard monolithic architecture to simplify deployment and development. And then I made some notes here. The business wants us to focus on time to launch. And you remember this is from the requirements document that we looked at before. And so this points back to it. And then so we can get real users on the platform and start iterating, which was one of the business requirements that business people wanted us to get real users on as soon as possible and start getting feedback from them. So given the scope and scale at this stage, a monolithic approach is cost-effective and straightforward to implement. Okay, so that's some of the reasons why we chose our architectural style. And then who are our stakeholders that we are designing with their considerations in mind? Of course, users. And perhaps at this point, we haven't interacted with any users, or maybe we had a previous version of the application or a UX person that did some user research. And then we have of course, our software developer team and any key technical people at the company. And then we also have any business owners, clients, stakeholders. So I'm just defining stakeholders here who have an interest in this project. Here are just some general system concerns that we're keeping in mind: performance, scalability, and security. And then I didn't have much to say about the system. I didn't go into depth about Docker and any of the other things that I'm doing. I just tried to keep it straightforward here. And then the architectural strategies. So I want to break this one down a little bit more. So some of the key strategies. So given the current experience of the team and the requirements for this project, we will use the following technologies. So I know not all architects or not all documents will include the tech stack. Some do, some don't. And sometimes that's a decision for the team. But in this case, of course, it makes sense to just define these things up front. This was in the requirements doc. Some details about the types of data we will have in the application were also in the requirements doc. So based off of that and the experience of the team, we made these technical decisions. And then we also had some security considerations to take into account when architecting our system. So these are some of the decisions we made based off of those things. And I think this is really an illustration of trade-offs. We will basically be using some libraries to manage our own passwords and the security behind them, our own authentication. And of course, this will help us ship faster, but it's a trade-off. It may not be as secure as using a third-party service for that. But we are planning with the future in mind, because we are going to separate some things like creating an auth table with a foreign key to the user table. We're going to kind of separate our security credentials to make it flexible so we can just swap that piece out later to use a third-party auth service when we need to in the future. And then how we're handling authentication, we're going to use tokens and pass between the front end and the API, and that's how we'll check for authorization on resources and objects. So an overview of the system architecture, the front end, back end, and database. And then here you can see there's some spots missing, or right here, 6.2. And this is where we're going to add some diagrams. So we're going to add a component diagram of the components of our system. And then also we're going to do a simple diagram of our database table, so an ERD. And these are the different tables. Of course, we're using Mongo, so these are collections. So we're going to start with 4 different collections. And because it's NoSQL, and we can reasonably have, maybe 2 layers of nesting in our tables. So for the curriculum, this collection, we're going to nest sections and resources just inside of this collection. So we don't need separate collections for those things. And that was one reason why we chose this style of database, because of our data and also because of the speed of initial development. And then I just broke down a list of the decisions, why we made certain decisions. Of course, this document is pretty brief, so it's pretty easy to see, but it's just nice to have this log of key decisions and just a summary of the reason for each one. And then we have some more information, any potential risks. Of course, some of the trade-offs that we're making might cause technical debt, since we're focused on rapid development and speed to market right now. So we have to take that into consideration. And then this is just boilerplate, nice to have just in case. So now I want to go back and fill in some of these missing diagrams using Eraser. So this is that same document here. I'm going to scroll down to the component diagram. And in this section, right now I'm in a document here, but I'm actually going to open up this right sidebar by clicking both. And now I should be able to draw a diagram inside here and put it over into my markdown file. So I'm going to draw a simple diagram here. And I'm going to start with the user interface section. And then I'm going to draw the second layer, so the back end, which is our Node Express app running on the back end. And then we have our database layer. You could do something similar for a class diagram, but I think this makes sense for our project right now. And now I need these objects inside. So this will be the authentication. And I'm just drawing the simple version here. And this will be, let's say, the curriculum UI and all the pages associated with that. And for authentication, we're going to have our authentication. Of course, it's not its own service, it's all in one backend. We can split out if we want to later. And for the curriculum, it's also going to be talking to different API endpoints. Let's say endpoints. Okay. And then inside our third layer here, we have our collections. So we have maybe the users and auth collection, and then we also have the curriculums or curricula. I guess it's two different words of doing the same plural word a lot in English. So curriculum collection or curricula collection. Okay. And now we can denote the relationships. So we could come here and say that this is the API calls, and then we put it to the side, and then we come from the backend logic to interact with the database using some type of ORM. So we can say we have read-write access to this table in the database. And then on the other side, we get things out of the database that we ask for. Well, I guess I already put read over there, or read. So this is actually should go both ways then. Or I guess I can update this. That way I can do the two separate arrows. So I can put read here, read, write, and then read. And then API calls, the opposite would be the return would be the response here. So these are the key components of our application. And then it's kind of a similar thing through the authentication layers. The API calls to authenticate, and then we reach out to check against the hashed password value, for example, and then we retrieve any information or get a response back, and then we send that response and any information back to the end user, and then we route them into the curriculum app, something like that. So this is a simple diagram, a component diagram. Okay, now that we created it, let's go and add it over here. And Eraser has these shorthands that you can use. Of course, this supports Markdown, but it also has these shorthands. So I typed in plus, and now I can connect it to a diagram. Okay, so I think I have to wrap all of this inside this figure wrapper instead of just each section, but let me see. Let me go back here and let's try this. I'm just going to call it component diagram. Well, I'll call it CA, curriculum app component diagram. Okay, and that's done. And now let me try that again. Let me try that. And of course, this is synced with GitHub. So I believe if I now push this back to GitHub, I can select a branch. Let me just do that for safety. Instead of just pushing to my main branch, I can just create a new branch. Let me just call this component diagram 1. Okay, and I'll create a PR for it. And let's just say adds component diagram commit. Okay, push to GitHub. Let me go back and see. Oh yeah, it's in a pull request. So in my file changed, it adds this link. That's interesting. Okay, but here is the, where is it? This is the actual diagram that I added. So I'm gonna see how that looks. Actually, I wonder if I can just use this link. I'm just checking real quick. Okay, so that takes me to the diagram inside of Eraser, and I guess this can be embedded now. So let me go back. I'm just gonna, oh, I can't approve my own PR. I'm the one who made this PR. But I can just merge. Okay, that's component diagram, confirm. Okay, now if I go back here, oh cool, it added this button for me. That was the link, open in Eraser. So I can open this document, and here's my component diagram. But this is just a link, so. Okay, so I'm cutting in here, and fortunately, Eraser has some pretty good documentation, so I went over and looked at the docs because I thought this was how to embed before, but actually it's even easier. So I can just come over here to my diagram and just copy it. So Control C and Control V, and now I've just embedded my diagram with the link to the diagram. So now I can get rid of this, and yeah, it's the same diagram and the link. So now let me push that, and I think, let me just push directly to main this time to save time. It's pushing to GitHub. There's a couple other types of diagrams that I want, but I'm kind of running out of time, and Eraser has this other feature that I want to try out, and they have basically an AI generator for docs, and I think that should work perfectly with an ERD. So I want to just generate some kind of simple ERD for these tables, and I'm going to see how it does. So let me come over here to, let's come to create diagram and this AI diagram, and then I can enter in the prompt that I have. So I need it to design from these 4 collections. I might just put in the type of database just in case. Maybe it will infer it from using collections here. Okay, so diagram type. These are also inferred, but I already know the type, so I'm just going to choose that, and then I'm going to click generate here. And let's see what it does. Okay, it's generating. Okay, this is actually pretty good. I think the code expires at, this is actually really good. I didn't even give it the list of each field, and it just inferred that. I do, oh, I guess somehow it put hash password here. Maybe I made that mistake somehow. But we do have, so in any of their diagrams in Eraser, they do have this domain-specific language for you to update. So here it's table definitions that I can update. And in users, I don't want the hash password that's already in auth. And then for this one, curriculum, it did make a couple mistakes. It's mostly right, actually. I guess the ID is a string. Okay, that's fine. But sections and resources should be objects. I don't know if it has it. Let me see if it auto-completes. Does it have JSON fields? Oh, I'm in the wrong one, actually. Okay. I meant to come in here. They don't seem to have JSON B fields. Oh well, it's not a big deal right now. I'll look at the docs. But yeah, that looks pretty good, other than it just having the password here. So I'm going to say save this and go back to both. And now, let me see if I can, well here, if I zoom out maybe. Oh, okay. Eraser ERD, diagram title. So let me just, oh yeah, copy. Let me copy this and paste it over here. Oh, I see. If I'm going to paste it over here and want more than the link, then this has to be a figure. That makes sense. Okay, so I can change this. There was some kind of option here. It says create figure. Okay, so now it's a figure, and now I can name it. Let's see. Just what it is, I guess. Okay, so now I created that, and I think I can paste. Yeah, okay. So now I can paste it over here. And now if I make updates over here, or I can even add comments or something over here, and then that will also sync with my GitHub. So I'm just going to push again directly to main to get that diagram over in GitHub. And I actually want to see what these diagrams look like embedded. It's still pushing. Let me go back. Okay, so here's the first embedded diagram. And I think the second one may have still been pushing. So let me refresh again. Okay, there we go. There's my ERD. It was actually very easy to create. I think it probably has slightly better support for SQL databases, which is fine. I almost always use Postgres anyway, and this is pretty easy to infer what it is. Okay, so those are two types of diagrams that I just added to my document, and you'll be able to see if you check this out on GitHub. I just wanted to take a few more minutes now to go into a different template for feature design. And this is really the one I more frequently use. And I kind of simplified this because I work at a startup. So I've been iterating on this document for a while, and I basically came up with the sections that I found really useful for general purpose. And I use this pretty much every time when I need to plan some kind of new feature or functionality, or if we want to, let's say we're going to implement a queuing system instead of the systems we have in place right now. This document just has worked really well for me. So I have an example that I kind of filled in here that you can see. So this is a new feature that I've been wanting to add to this curriculum app. It's the ability for users to fork other users' curriculums. So if, let's say I made a curriculum, let's say I want to learn bare metal C or something, and I created all my resources and projects, everything around there in my curriculum, and you want to use the same curriculum, you could just hit fork and copy it, and then that way you can track your progress on your own and also make updates or changes to the curriculum and save it for yourself. So this is that feature to be able to fork and clone. It's intended to enhance the collaboration and community aspect of the app, foster a culture of sharing and continuous learning. So these just talk about some of the goals of this feature, and then it describes the functionality, the project scope, like which pieces need to be changed, and it's pretty much, I mean, we have a pretty small stack, so it's not like we have a bunch of different services, so it's going to change every layer of the application. I guess I could be more specific in the project scope here. And then here are some strategies. There's no diagram because I wanted to add it here. This is the strategy that was selected to implement this feature. Of course, this might iterate or be different based off of a design and UX feedback, because this is kind of a UX decision a little bit. But anyway, ensure proper permissions. This is definitely something we have to take into consideration in terms of security and privacy. And then we need to allow users to modify and save the clone curriculum independently of the original. And then we're going to add the diagram, some about the system changes, and then here are just some notes about the decisions and trade-offs that we're making, why we made certain decisions. And then I also added this piece about some milestones for the project if we wanted to break it down. Okay, let's finish the architectural planning, let's do the API and database development, and then UI implementation. And if we had, for this feature, I couldn't very quickly think of maybe more milestones to roll out. Maybe we could roll out an MVP of this feature, and then we have just to get users starting to use it, and then we have version 2, etc. So back here in diagram, we can open this up over in Eraser, and let me go back to my project here. And this, so the last one was the greenfield design, and now this is the feature example for forking and cloning curricula. And now down here, where is the diagram? Oh, here it is. It's nested inside. Okay. Well, that kind of changed. Oh well, I'll change this later. But anyway, I want to add a diagram here. Or I wonder if I'll try to just add it nested in here. See what happens. Okay, so I'm going to open up the sidebar here, and I'm going to start with this diagram as code and kind of tell it what kind of diagram I want. I actually want this sequence diagram for this case. If you haven't seen a sequence diagram before, you see these a lot, I think, especially in authentication or for login, logout, register, auth service. So you see services like Auth0 and Cognito in their docs. They have a lot of these types of diagrams. So here I just want to basically denote the different tiers of our system. So the client, and then the server, and then we don't really have any external services. So we have the client, and then we have our API running on the server. So I'm just going to change, oh right, because this is a diagram that is generated from this domain specific language here. So I'm going to update it over here. So let's change, I'll just simplify this. Let's just call it front end. And then this will be API and API to, okay, it didn't like that dash. All right, so front end to API, and then API to database. And then, oh, we still have service here. Actually, I'm going to take service, and I don't need this really, so maybe I can get rid of that. Yep, I got rid of all that. And now let's see what happens if I take those away. Okay, so now I have the front end API and database, and this is of course specific to the feature that I'm building for forking and cloning. So I can add, let me just add one more tier here to make it a little bit more interesting. So I think if I add another layer, let's do user, and let's just say this will be a very clear definition of what's going on. So clicks, yeah, fork button. And this would actually, oh, we switched things around here. Let's change it. Okay, so the user clicks the fork button, and then the front end sends the data request. So I guess it's like the fork request to the API. And then I'm not sure what this is doing. Didn't do anything. Okay, so I can get rid of that. And then the API will communicate with the database. It will request to duplicate the curriculum, of course. Well, let me see if it overflows well. Yeah, looks good. Okay, request to duplicate the curriculum, and I could leave the arrows both ways, but it kind of, the request is one way really, and then the other way is, wait, it's this. And then it responds, let's see, responds with the new curriculum ID, because we've just created a new one that's associated with the new user. And then we can, from the API, right, we can do API, I don't think I need the icon every time. Let's see if I can get rid of that. Cleans things up a bit. Okay, so I'm actually going to clean this up too. Maybe I can use it for something else. But anyway, so the API will go back to the front end, yeah, with a success message. I guess success or failure, but we'll just leave it at that. And then our user is happy because our user can see the new curriculum. Okay, and I don't know how to do everything yet, like use dotted lines here, but I think this is a pretty good basic representation of what's going on. So now that I have this, let me, open up the document part. And where is my diagram? Okay, so I copied it and it's just giving me the link. So let me do the same thing as last time when we did the AI diagram. I'm going to just put it in a figure. Oh, come on. Okay. And I'll name this figure, what is this? User fork flow. Let's see. Curriculum fork flow diagram. Okay. So let me copy this now and paste it here. Maybe it's not pasting because it's nested. There we go. Okay, so it can't be nested to paste apparently. But anyway, there's my diagram. And now can I change this to start with 5? No, it just automatically goes to 1. Oh no, it did. I think I did something else accidentally. Okay, good. So now it starts where it should at 5. Those are still nested. And I have my diagram. So let me also push this, let's say, to the main branch. Okay. And I have to wait a minute for that to update. Awesome. So now it says I'm in sync again. And if I go over here, I should be able to see my diagram. Yep. That's my flow diagram of this feature. Awesome. One more thing I just realized is that these embedded diagrams here are actually saved to this eraser folder. So you can see all of these diagrams. That eraser just created this folder for us. And I guess I would have seen this if I had created a new branch and a PR, but instead when I was actually, embedding the actual diagram, I just pushed directly to main. So I just wanted to point that out in case you try this out later. A couple other things I just want to mention here. Again, I have some terms and definitions in this document. I might add to that. These are some common terms that I've just come across and taken notes about as I was studying architecture. So they're good to know about, and you can use that as a starting point for some of your research. A couple other things that I included. So career paths. So typically, if you look at, I guess, a traditional software architect, of course I had the other definition, the easier definition getting started, but it's just a software architect role, and then you'll hear of enterprise architects working in kind of a larger scale organization. And now they have all different kinds of domain or other types of specific architecture jobs. So you've probably heard of solutions architect, that's a pretty common one, cloud architect in cloud providers, and then of course there's security architects, and network architects are somewhat separate from software development. And then some people debate about these last couple if they can really be considered architects, but they do have roles for specifically front-end architect and for back-end, and this is something I've done before, so worked kind of playing the role of an API architect for what we're building. And I do think this absolutely matches the definition of an architect. And you basically, for any of these, you follow the same steps of working as an architect exactly from the getting started document that we went through. And you're still analyzing things and considering trade-offs, etc., no matter what type of architect you are. So generally, some of the most important skills for a software architect: deep technical knowledge and understanding of application development in whatever domain you are working in. But also you have deep knowledge, but also being able to zoom out and look at the big picture, which is something a lot of people struggle with. And then a critical piece of being an architect is you need to be able to have communication skills for, of course, describing and breaking down problems and solutions to technical people, but also for non-technical audiences, and being able to get buy-in from non-technical audiences, stakeholders, meaning you have to get along with people and also really be able to articulate your ideas and argue your perspective well. And then one more key skill that I think is important for software architecture is to really keep up with new technologies and tools. Now that might vary by domain. Like if you're a cloud architect, you'll just focus on cloud stuff mostly. In whatever domain you're in, I think it's really important to keep up with new technology and tools, and that way you can really design for the current needs of your users and systems, and also prepare for the future and what's coming down in the pipeline. I also included this other document about practical tips and best practices. So you can look this over. Some of these things I mentioned before, and some of them I just want to emphasize and mention here. And then if you go back to the README here, you can see there's this learning resources link, and that actually points you to this blog post that I just posted, helpful resources to learn software architecture. And I just tried to collect some resources and then boil them down to what I thought would be the most helpful and the things I liked the best. So here are a couple videos and then some of the books I really like. Now, if you're brand new to not only architecture, but also kind of newer to software development, I highly recommend you read this book, The Missing README, and that includes a section about just basic architectural considerations in there. And then there aren't really many dedicated podcasts, but here are a couple podcasts that I like, and they include some episodes on architecture. Actually, this one is about architecture, but they haven't posted a new episode in a while, but I still found some of their episodes to be really helpful. Here's a monthly newsletter about software architecture that I get. And then I also highly recommend you check out something called the C4 model if you're really getting into architecture. And this is just a set of recommendations for how to visualize and communicate about your software architecture in ways that make sense. Sometimes it's hard to know how to diagram or what to show to your stakeholders, and this system was really helpful for me to learn about that. That's all I have for today. If you have any feedback for me, I would love to hear it. You can leave it in the comments below, or you can join me on Discord, which is also linked in the description below this video. I've been waiting for so long to do an architecture video, so I'm very happy to be able to finally put it together from the thousands of notes I've been taking over the last however many years. And I'm very happy that Eraser sponsored this video and helped me to finally push myself to do this dive into software architecture. I do want to make a lot more follow-up videos to this topic, so stay tuned. Thanks so much for watching, and I will see you in the next video. Take care.